Hello, and welcome to BrushMyQuant channel. If you want to increase your knowledge of maths and wish to receive regular updates from us, then consider subscribing to the channel by clicking on the subscribe icon to the right bottom of this screen. So let's get started with today's topic of a problem on remainders. If you want to go through theory of remainders, then I have provided a link to the same in the description of this video. This problem we have taken from GmatClub, and the source of the problem on GmatClub was mentioned as others at the time of recording this video. So let's go ahead and solve this data sufficiency problem together. So if n is a positive integer, what is the remainder when n multiplied by 2n minus 2 multiplied by n plus 1 whole square is divided by 32? And we are given two statements. So if we go ahead and simplify this expression, we can rewrite this by taking 2 common as 2 multiplied by n into n minus 1 into n plus 1 whole square. We can bring n minus 1 over here to have it as 2 multiplied by n minus 1 multiplied by n multiplied by n plus 1 whole square. And we need to find whether it is divisible by 32 or not. 32, as you know, can be written as 2 raised to 5, and we already have a 2 here. So that means we need to prove that this expression is actually divisible by 2 raised to 4, right? So till the time we are able to prove that, it is sufficient for us to go ahead and answer the problem. Now, how can we get 2 raised to 4? So let's say n is an odd number. So if n is an odd number, that means both n minus 1 and n plus 1, which are one number before and after n, will be even numbers. If we take n minus 1 as an odd multiple of 2, that means if n minus 1 is, let's say 2, 6, or 10, then n plus 1 will become a multiple of 4, and this will become 4 square, and this will become 2 raised to 1, making this entire thing a multiple of 2 raised to 1 multiplied by 2 raised to 4, which will definitely be divisible by 2 raised to 4. Now, other case can be n minus 1 is a multiple of 4, and n plus 1 will be an odd multiple of 2. So let's say that is 4 and this is 6. So we will have 4 multiplied by 6 square, and this becomes a multiple of 2 square into 2 square, which is again 2 raised to 4. So in all the cases when n is odd, definitely this expression will be divisible by 2 raised to 4. Now what happens when n is even? So let's say n is 4, then n minus 1 becomes odd number, and n plus 1 also becomes an odd number. Definitely this is not divisible by 2 raised to 4. Similarly, if let's say n is a number like 16, then in that case, this expression will actually be divisible by 2 raised to 4, right? So in some cases, it will be divisible by 2 raised to 4. In some cases, it won't be divisible by 2 raised to 4. So that means we cannot answer the question if n is even, but we can definitely answer the question when n is an odd number. So let's see which option actually provides us that value of n, which is an odd number for sure. So if we take the statement 1, it says n leaves a remainder of 2 when divided by 3. That means n can be written as 3k plus 2, and sample values of n can be 2. When we put k is equal to 1, then it becomes 5, then it becomes 8, and so on, right? So in some cases it is odd, in some cases it is even. That means we cannot answer the question definitely by statement number 1. Similarly, if we take statement number 2, n leaves a remainder of 1 when divided by 2. That means n can be written as 2t plus 1. Now, since it is 2t plus 1, that means n for sure is an odd number, and possible values of n are 1, 3, 5, and so on. And we know that in all the cases when n is odd, this entire expression will actually be divisible by 2 raised to 4. So that means statement 2 alone is sufficient to answer the problem, and our answer will be nothing but option number B. Thank you for watching the video, and thank you for your time.